basic electronic circuits as linear systems. Most electronic circuits can be represented as a system with an input and an output as shown in Figure 1. The input signal is typically a voltage that is generated by a sensor or by another circuit. The output signal is also often a voltage and is used to power an actuator or transmit signals to another circuit. Figure 1. Electronic circuit represented as a linear system. In many instances, it is possible to model the circuit as a linear system, which can be described by the transfer function h, such that h is equal to V out by V in. For DC signals, the linearity of the system implies that h is independent of Van. For dynamic signals, the transfer function cannot in general be described simply. However, if the input is a sinusoidal signal, then the output must also be a sinusoidal signal with the same frequency but possibly a different amplitude and phase. In other words, a linear system can only modify the amplitude and phase of a sinusoidal input. As a result, if the input signal is described as a complex exponential, V in t equals to e to the power minus j omega naught t, where a is a complex constant. A equals to mod of a e to the power minus j phi. The transfer function h can be entirely described by a complex constant. H equals to mod of h e to the power minus j phi h. And the output signal is simply V out t equals to h e to the power minus j omega naught t. In general, the sinusoidal response of linear systems is not constant over frequency, and h is also a complex function of omega.